Now let's write the Python code for finding the intersection of two arrays. So as part of the first step, before we go ahead and write any logic here, I have copied the binary searching algorithm whatever we have implemented previously. I've added it into this class as well so that we can reuse it later on. Now this function is where we will be writing the logic for finding the intersection of two arrays. So as part of the first step, what I want to do is I want to sort the second array. Okay, now let's just create one set data structure in which the intersection values can be added and in the end they can be returned. So here let's just define one variable result list and initialize it with a empty set python set. Now I want to iterate over the first array, and each and every value in the first array we will check if it is also available in the second array as well. If it is also available, then we will add it onto this set data structure. Remember, here we are using set data structure because even the intersection values should also be unique. That means if the common values are available multiple number of times in both the arrays, then we should add it only once in the result list. That's the reason why here we are maintaining set. If at all, if it is okay to return the duplicate values, we can simply use a Python list as well. The reason for usage of set is that. Now here anyway, let's just iterate over the first array. For I in range of length of array 1, what I want to do is whatever the value we have at this ith index from array 1, we will check if it is also available in array 2. That is the reason why we have sorted the array in the ascending order, so that we can apply binary searching technique on that for searching a particular value. So here let's just call self.binary search, and the array we need to pass is sorted array, which is nothing but array 2, and the value we want to search is the value at ith index from the array 1. Okay, and this binary search function will basically return the particular index if at all whatever the value that we are searching is available. If it is not available, it will return -1. So here let's just capture the returned value in some variable. Now here if at all this array 1 of I is not available, then we would get -1, right? So let's eliminate not available case. If at all the index I'm getting is greater than or equal to 0, then only the value is available in array 1 and it is also available in array 2. So that I can add it onto the result set that I'm maintaining. So immediately result list dot add of whatever the value at ith index from the array 1. Since anyway result list is of type set, even if we try to add duplicate, it will get replaced with only ones. Okay, and once we process all the values from array 1 and we check if it is available in array 2 and add it onto this result set, in the end we will simply return result list directly. Okay, so that is the way of finding the intersection of two arrays using binary searching technique. So here the that is the implementation, right? Anyway, let's just validate it by calling it on certain number of inputs. So array 1 that I'm passing here is 1 2 3 3 4, and the second array is 3 3 4 5. So array 1 has 3 and array 2 also has 3, so it is a common value, so we will add it onto result. Now 3 is there, again second 3 is also available in both the arrays, but previously itself 3 we have added it onto the set data structure. Even if we add, it will get replaced and it will be coming only once in the result list. And 4 is there in first array and 4 is there in second array too, and it is unique. First time we are adding onto the set. So the ultimate result for this input set would be 3, 4.